Hey everyone, this is the answers to the chi-square part of your math review. There were only two chi-square problems, and according to the calculations, the answer to the first chi-square is 4.74, which means we failed to reject the null hypothesis. Then, for the second problem on the back, we find that the p's follow traditional Mendelian genetics because our chi-square value was 0.301. And according to our degrees of freedom in our critical value chart, the chi-square is less than the p-value of 7.82. So if you want to see how I did these calculations, then just keep watching. Okay, so to start with the tiger and the cheetah cross, the questions that are up here are designed to kind of help guide you. And when you're looking at these calculations, 4 out of the 16 have stripes, so that's going to be 25%. Spots only was 3 out of the 16, which is 0.1875, and then stripes and spots together was 9 out of the 16, so that's just a little over half. That was the data that was given to us in the word problem. Now, the actual calculation from the cubs that were produced were 176 cubs. So now what I'm going to do is I'm going to take the data from here and use it to fill out my chi-square chart. So our expected ratio, 4 out of 16, meant that 25% of our offspring should be stripes only. So our expected value would be 176 times that percentage, which is 44. For spots only, it was 3 out of 16, or 18.75%. That would mean that 33 of the 176 should have that trait. And then my 9 out of 16 is a little over half. That is 99 is our expected value for a little over half of that 176. Now what I'm going to do is I'm going to take the observed values. These are the values that were actually produced by the offspring itself. And again, this should come out to 176. And now what I'm going to do is the rest of my chi-square calculations. So this becomes 6. 6 squared is 36. The expected value the observed minus expected squared divided by the expected is 0.81818. Then I'm going to do the same thing, 41 minus 33. 41 minus 33, which is 8 squared. And then I'm going to do my observed minus expected squared over the expected. Sorry, that should be a 3. And then I'm going to do the same thing here. So 85 minus 99 is 14. Squared is 196. Divided by the expected value, 8. Now to calculate the chi-square, you're just going to take this column, add them up, and that is your chi-square value. Because there was 3 options or 3 characteristics, that means my degrees of freedom is going to be 3 minus 1, which is equal to 2. And on the chi-square table, we always use 0.05. So we're looking at comparing our chi-square to 5.99. Since our chi-square value is less than 5.99, we fail to reject the null hypothesis. For the second problem, you will need to have a dihybrid cross done in order to find out what our expected values are going to be. If you need to at this point, go ahead and pause to check your answers. Notice that since we're looking at phenotype, if it has at least one dominant phenotype, I didn't write both of them in. I'm trying to save time and trying to make this process a little faster. So a tip that you might use on the AP exam on it as well. If it has at least one of the dominant traits, you don't need the second one because the phenotype will be expressed as dominant. So if you need to, go ahead and push pause to count up or check your dihybrid cross. Otherwise, I'm going to go ahead and move on to the next side. And on the next side, I'm going to fill in what my different expected values were. So yellow inflated, yellow constricted, green inflated, and green constricted. And our expected ratios came out 9, 3, 3, and 1. And what I'm going to do now is take these values, take these ratios, and use them to predict what my expected values would be based on the fact that there are 994 seeds that were produced and counted. So 9 out of 16, I convert that to a percentage and I multiply it by 994, and that's where I'm going to get these expected values from. So when I show you the original answers, you can see that I still have the ratios here. Here are the expected values. Again, I got by multiplying the total times my expected ratio, so 0.5625 times 994 comes out to 559.1, and I just left the decimals in there. And then I was able to fill out the rest of the chart, and that's how I got my chi-square of 0.301. My degrees of freedom was 3 because there were 4 variables or 4 phenotypes minus 1. So my critical value that I was comparing it to was 7.82.